Hi there and welcome to this video on Senior Physics on Motion. In this video we're going to explore the idea of vectors. What is a vector? How do we add them and subtract them? And then basically how do we combine vectors which are going in opposite directions, which are basically in two dimensions. Okay, so let's just start right at the very beginning and look what a definition of a vector is. Now we saw in our previous videos right at the beginning of this course that basically a vector is a quantity that has direction as well as magnitude. And as a result, it's going to work out the position of one point in relation to another. Now basically a vector is an instruction, and it's denoted by having often a symbol which then has a cap or a line which is placed on top of it. And as I stated, it gives you an instruction to do something. So first you would do one vector and then you would do the next vector. Now they don't always add together in the way that we conventionally put 2 plus 2 to equal 4. So we're talking about a direction and an instruction at the same time. Now we can represent each vector using an arrow. And of the arrow, the length basically is going to relate to a magnitude. And as we state, this is often going to be scaled. So for example, you might say, let 5 centimeters equal 1 kilometer. And as a result, by measuring the length, you can actually determine the actual size, the accurate size of that magnitude. Now, also you can do the direction. The arrow will show the direction. Now this is self-explanatory. The direction that the arrow is pointing is the direction that you happen to be going. Now obviously we can add this by using compass headings and bearings, and this then allows us to determine in what direction the vector happens to be going. So as an example, you can see here is a vector, vector A. It's made with an arrow, and you can see it's a vector because it's got a cap on the top of it. There's also vector B, and there's vector C. So we've got a variety of different vectors all going in different directions. Okay, so what happens when we add vectors together? Well, the key thing to understand is when we take two vectors, we always top and tail them, or head and tail them. Basically, you do the first instruction and then you add the next vector to the head via the tail for the second vector. So for example, if I've got vector A plus vector B, it will equal vector D. So what does that mean? Well, basically, if I take vector A like so, and then I add to it vector B, I will place the tail of vector B on the head of vector A, just like so. Now, the effect of doing vector A and then vector B is the same as doing vector D. So it's going in a different magnitude and in a different direction. So just to recap, basically an equation, vector A plus vector B equals vector D, means do vector A first, then place vector B, placing the tail of vector B on the head of vector A, and this is the same as doing vector D. So we need to note that to calculate vector D, you can't just add the lengths together because we're going to get a totally different vector which is going to be generated. Our direction also has to be considered. Now, we can use accurate vector diagrams by literally drawing the arrows to a scale diagram and then literally measuring what vector D is and then using a protractor to work out the direction. Now, later on in physics, you will actually learn how to combine these two vectors A and B together and basically generate the same vector D, even when they're not producing a right angle triangle. But in this unit, we're literally going to go as far as a right angle triangle that's going to be produced, and that will make more sense towards the end of this video. Okay, so we now know that if we're doing any addition, basically all we do is we add one vector to another, we do one instruction after the other, head and tailing our vectors. Okay, so what happens when we subtract our vectors? Well, basically we do exactly the same as we do for addition. The only difference is that when we're subtracting, we're using a negative value. Now, instead of taking it away, what it actually means is we change the direction of that vector. So for example, if I wanted to look at vector A minus vector B equaling vector E, what it means is that I do vector A first, and then I do minus B. Now remember, from the previous question, vector B goes straight up. But in this case, because it's negative, I've got to go in the opposite direction. Negative meaning opposite. So as a result, B will go downwards. It will be the same size, but the direction will change. So whenever we get a vector diagram or a vector equation which has a negative in there, what it means is we've just got to change the direction to the opposite direction for that specific vector. As a result, by doing vector A minus vector B, we get a totally new vector, which we call vector E. Okay, and you can see there by the red line. Now, the red line E basically is going to be our resultant vector. It's the result of vector A minus vector B. So it's different than using straightforward numbers where you take maybe 3 for A minus 2 for B equaling 1. These are instructions that are going to ask you to do the first vector followed by the second vector. The plus or minus determines the direction, whether we keep the direction in the same way as it's shown or whether we use a different direction. We change the direction, so it's going in the opposite way. So to recap, this equation means we do vector A, then we do vector B, but in the opposite direction because it's negative. The result is we get vector E. So doing A minus vector B is the same as doing vector E. As a result, we get a brand new vector which has been created with a different magnitude and a different direction to what we had in our previous example when we looked at addition. Okay, so what we're going to do here is have a look at a few simple vector diagrams that we can deal with respect to using addition and subtraction, but in this case we're going to use them on the same plane. So it's basically going to be a 1D diagram. So let's have a look at the first example. In this case we're going to have a vector A equaling 5 meters. So I'm going to produce an arrow which is going to represent my 5 meters and it's going from left to right. I'm going to have vector B equaling another arrow going in the same direction, but it's only 2 meters long. So I'm going to try and solve the equation vector A plus vector B. Now if I put that together, it's the same as saying 5 plus 2, which equals 7 meters. And in this case, it's going in an easterly direction, going across my page to the right. Now, why do I add these two together? Well, basically the two lines are going to be added together because they're going in the same direction. So I'm doing two specific vectors of specific magnitude and they're going in the same direction. So as a result, I can add them together. However, what if I had a situation that looks like this? I've got vector A, 5 meters, and I've got vector B, but in this case it's going in the opposite direction. How does that work? How do we solve or resolve and find the resultant of this situation where I do vector A plus vector B? Well, in this case, we're going 5 meters in an easterly direction, then we come 2 meters back. Now I've learned from your basic displacement work, we then take the 2 away, basically because we've got to take into account that vector A is going easterly and vector B is going westerly. So I've got to take the 2 away, and the result of that is I will end up 3 meters east of home. So just to recap, if I do vector A and then do vector B, I go 5 meters east and then I come back on myself 2 meters west. Where do I end up? The answer is 3 meters east from home. I hope that makes sense. So let's have a look at what happens when we do some subtraction. So all I've got there is the minus there is just showing that we're going in the opposite direction. So again, I'm using the positive and negative to denote the direction that I happen to be going in. All right, so we're going to subtract them now. So let's have vector A again, 5 meters. I've got my vector B, which is going to equal 2 meters, but I'm going to change my equation. I want to do vector A minus vector B. Well, if we look at this now, what does this mean? Well, the negative means I've got to go in the opposite direction of B, which means instead of going east, I need to go west. So as a result, I have to take the values away. So the minus basically means I've got to swap the direction for the vector which comes after it. So I do vector A, and then I've got to do the opposite direction of vector B. As a result, I end up 3 meters east of home. So let's take the same scenario, but in this case where B is going in the opposite direction. So I've got vector A, 5 meters going east, and I've got vector B going 2 meters west. So what if I do vector A minus vector B? Well, remember what the minus means. The minus means I've got to change the direction. So in this case, if I change the direction of vector B, I'm going to be going in the same direction as vector A, which means I'm going to do 5 meters east, then I'm going to do 2 meters east. So I've got to add the two together. So as a result, a slight mistake there, it should be 7 meters east, not 3 meters. So I've got 5 plus 2, which gives me 7 meters to the east of home. So that positive is made up of the change in direction of B. So I hope that makes sense. So that basically deals with positive addition and subtraction vectors on the same plane. But what happens if they're not in the same plane? What if we go into 2 dimensions? Now in this case, we basically will produce right angles. Now at this level, we will only deal with right angles. However, it is possible, and you may study this in Maths C or in your further maths, it is possible to use the idea of resolving horizontally and vertically across 2 different vectors to get an overall resultant. But we won't deal with that in this area. So all we're going to do is formulate vectors which are going to produce a right angle. So we produce a right angle triangle. When we produce a right angle triangle, we resolve either using Pythagoras or trigonometry. So as a result, we're going to find the resultant vector of this following situation. I've got vector A going at 6 meters, and then I've got vector B going at 3 meters. So what do? I've got my compass heading going in a northerly direction. So A is going to the east, B is going to the north. Then what happens is I combine them together using a top and tail method, just like we did earlier. Vector A goes to the right, and then vector B goes straight up to the north. The result of that is I'll get vector C. Now, I can work out the magnitude of vector C using Pythagoras, and I can use the direction using trigonometry. So let's try and resolve it. So in this case, I've got doing vector A plus vector B is the same as doing vector C at angle X. So let's work out the magnitude of C. So I know that A is going to be 6 meters, and I know B is going to be 3 meters. So basically, vector C will be made up of the square root of 6 squared plus 3 squared. Simple Pythagoras. And the result is it's 6.7 meters. To work out the direction, I need to find the angle X. Well, angle X is going to be made up of the inverse tan of 3 over 6, which comes out at 27 degrees. As a result, I can combine these together to get my resultant vector, C, which is going to be 6.7 meters. East, remember that's my start bearing, 27 degrees, that's the angle I'm going to turn through in a northerly direction. So 6.7 meters, east, 27 degrees north. I hope that makes sense, and hopefully that will allow you now to resolve on one plane, adding or subtracting your vectors, and then on 2 planes using Pythagoras and trigonometry. If you follow these rules, you're not going to have any problems resolving any form of vectors. So check out the worksheet and interactive links. I'm also going to be generating a worked example for you as we run through probably one of the harder questions, which allows you to combine a variety of different things. So I do hope you found that useful. Do join me again, and I look forward to you watching my videos. Thanks for watching.